Mr. Heffern here, and here's a short video on how to do a ray diagram for a diverging mirror. So here we have a convex diverging mirror of radius 10 centimeters. So once again, your focal length is going to be half of your radius, so it'll be 5 centimeters. And we have the robot's 4 centimeters tall, and it is 2 centimeters. Let's fix that. 2 centimeters in front of this mirror. So we want to find out where the image is going to be located. So first thing I'm going to do is grab a ray and make it parallel to this principal axis line right here. Okay, now when it hits the mirror, it's going to bounce away from the focal point. So here's the focal point right here. It's going to bounce away this direction. So I'll just bounce it up. There we go, like that. Oops, got the wrong thing there. There we go, like that. Okay. Now you have to draw an extension line this time. So we're going to draw an extension line. It's going to go from our diverging ray there, and it's going to go towards the focal length. And just to show that it's going into the mirror there, I'm going to change it to be a dashed line. There we go. Okay. So that's one ray. If it's parallel, it bounces away from the focal length points. There we go. So the next one I'm going to do is I'm going to aim it towards the center point like this. So here's the center point. And what's going to happen to this ray is it's just going to bounce right back. So it's going to bounce the other direction. And what we can do though is we actually can draw an extension line from there, like this. There we go. There we go. And that will actually go through the center. But this is an extension line, so we're just going to change that to be a dashed line as well. Okay, so now we can see where the image is going to be. The image is going to be, there we go, I got my object there. Okay, the image is going to be right here. So it's just going to be a lot smaller than normal. That big right there. And there we go. Okay, that's where our image is going to be located. So as you can see, it's going to be inside the mirror, so it's virtual, can't put a screen there. And it's going to be smaller, and it's still standing up, so it's going to be upright. So we're going to get upright, virtual, and it's definitely smaller. There we go. Okay, now if you decide to go for a third ray, what you can do is aim it directly at the focal point, like right there. Bring it back. It's going to bounce back parallel like this, and then you can draw an extension line for that, and the extension line will go right here, just where the head is, and just to show that is an extension line, also make that a dashed line. I'm just going to flip this one vertically to horizontally. There we go. So you can see all three lines do match up in the right spot. Now let's find out what the values are mathematically so we get a better idea. Okay. So first of all, if you're using the this formula here, you can find out what the focal length is. So we have a 10 centimeter radius. So if we divide that by 2, we're going to get our 5 centimeter focal length. Notice this time we're using the focal point which is inside the mirror, so that's going to be a negative 5 centimeters right there. So we have to be careful to remember to do that when we use the formula. So that's going to be negative 5 centimeters this time. And the object, let's just go back and take a look, it was 2 centimeters in front. So I'm going to put the 2 centimeters right here. There we go. Alright. So now what we have to do is solve for DI. So I'm going to bring the 2 centimeters over to the other side. So we're going to have 1 over 2 centimeters on this side over here. There we go. Okay. Now, what's the common denominator for 5 and 2? It's 10. So that's going to be 2 tenths. And that is going to be 5 tenths. There we go. Okay. So we're going to get negative 2 tenths, subtract 5 tenths. That's going to be negative 7 tenths altogether. So we have negative 7 tenths. There we go. And so if we flip that, the DI will be equal to 7. Oops, there we go. Come on. It's going to be equal to 10 sevenths. There we go. So let's just grab that. So it's 10 centimeters divided by 7, and it's negative. Just put a minus sign in. Now you can find out what the exact value is as a decimal, just using your calculator. So we get 10 divided by 7, and we get 1.43 approximately. So negative 1.43 centimeters. All right. Just take a look at the picture to see if that makes sense. So if this is a 2 centimeter line right here, and we put another one here, you can see it's about right here. It's going to be about 1.43. Well, it's a little bit off because the diagram is not to scale, but there you go. Around 1.43 centimeters. So now we're just going to find the magnification and the image height. So we're going to use this equation for that. So we got an image distance of 1.43 centimeters. The object distance was 2 centimeters. There we go. And the object height was 4 centimeters. There we go. Alright, so we filled in as much as we can for this formula. First, let's calculate the height. So we're just going to cross multiply the 4 centimeters over to the other side, right there. Okay. And this will tell us the height. Okay, and oh right, that was a negative of a negative, so I forgot to put the minus sign in there. I better do that. Alright. Okay, so since I still have my answer on the calculator, I'm just going to multiply by 4 divided by 2, and I get 2.86 approximately. So for my image height. So let's just do that. So 2.86 centimeters approximately. Good. So a positive number, so it's upright. Now to get the magnification, I just have to grab part of the formula. Just grab this part right here. Okay. So we got negative 1.43 divided by 2, and that works out to 0.71. So the magnification is going to be 0.71. So just write that down, 0.71 times, or approximately 71% of what it used to be. And that looks about right. Okay. And there you go. That's how you can do the math to find the location, the radius, and the focal length, sorry, and the magnification and the image height. Alright, so those are the values right there. Okay, it would be nice if I could just shrink that down a little bit. There we go. So you'll see it better. And there we go. Okay, and that's what it looks like for the ray diagram. Alright, good luck.